Alright, boys and girls, welcome to our third video lesson in Chapter 6, our continuing quest to solve an oblique triangle. This is our lesson on 6-2, the law of cosines. Okay? In class, we will derive the formula for the law of cosines using a triangle, an oblique triangle. It's a pretty cool derivation, and we'll see that in class. But the law of cosines is this: a squared, any one side of an oblique triangle, is equal to b squared plus c squared minus 2bc times the cosine of a. If we solve this for cosine a, we get cosine a is equal to b squared plus c squared minus a squared all over 2bc. If you look here, okay, if you only want to memorize one, and I would suggest that we want to memorize this one here because it's more like the Pythagorean theorem than the other one. And you really, I would rather have you just memorize the one thing because this will always take care of everything we need to know. Okay, so we look right here. We look at this oblique triangle. This is in an SSS situation. So as if we look at our chart, we can see we're going to use the law of cosines. My general rule for the law of cosines is always start with the biggest angle and or the biggest side. So if we look right here, let's find angle C. I know that's going to be the biggest angle because it is opposite the biggest side. So I'm going to use my law of cosines, and I'm going to write here c squared, that's little c, is equal to a squared plus b squared minus 2ab cosine angle C. So I'm going to solve this for angle C by plugging in what I know. I know that C is 11, so 11 squared is equal to a squared, which is 9, plus b squared, b is 3, minus 2 times a, which again is 9, times b, which we know is 3, times cosine c. So we're going to whip out our calcs here. 11 squared is 121, is equal to 9 squared, which is 81, plus 3 squared, which is 27, minus 2 times 9 times 3, which is 54, cosine c. We're going to solve for the term with the cosine c in it, so we're going to add the 81 and 27, okay, and subtract that from 121. So now I'm going to get, let's see, 81 plus 27 is 108. It looks like 13 is equal to negative 54 cosine c. Okay, so to solve this for cosine c, I'm going to divide both sides by negative 54. Let me get to a new slide here so I have some room to write. So I have 13 divided by negative 54 is equal to cosine c. Well, 13 divided by negative 4 is negative 0.24074. is equal to cosine c. Whip out your magic graphing utilities and let's do an arc cosine of negative 0.24074. So we're going to do second cosine, negative 0.24074. And we get an answer of 103.93. So that means that angle C is 103.93. Let's move on to a new slide again. I now know that the angle C is 103.93. So now I can use the law of sines to solve for either angle A or angle B, and it doesn't really matter here. I'm using the law of sines, so let's always solve for the smallest angle. So I know that sine of B over 3 is equal to the sine of 103.93 all over 11. Whip out your graphing utilities, and we know that we're going to cross multiply and get 3 times sine 103.93 divided by 11 is going to equal some decimal. I get sine of b is equal to 0.2647. So now let's do an arc sine of that, and we're going to find that angle B is equal to 12.9 degrees. Now to solve for angle A, I can either use the law of sines, or much simpler, I can just subtract from 180. I'm going to subtract 180 minus 12.9 minus 103.93, and I'm going to find that angle A is 42.07. I have now solved this oblique triangle for my 3 missing angles. Alright, let's do another one. Okay, so if I look at this guy right here, I can see I have a side, angle, side situation. That's side, angle, side. Here's my side, here's my angle, here's my side. So I'm going to use the law of cosines and solve for little c right now. So I know that c squared is equal to a squared plus b squared minus 2ab cosine c. So therefore now I'm going to throw in my values. C squared is equal to a squared, which of course is 10 squared. B is 7, so that's 7 squared, minus 2 times a, which is 10, times b, which is 7, times cosine of 108. Okay, so now I have c squared is equal to 100 plus 49 minus 2 times 10 times 7 is 140 cosine 108. Whip out your magic calculators and let's punch these numbers in. Okay, we should find that c squared is equal to 192.26. Please make sure you are getting these numbers on your calculator when you're doing this. It's important that you know how to press the buttons. We're going to take the square root of that side of both sides now to solve for c. So c is equal to, hold on here, I'm hitting my second radical, 192.96, and we should find that c is 13.89. So now we know that c is 13.89, so that's 13.89 right here. I'm going to use my law of sines to find my next angle. Because I'm using the law of sines, I'm going to be in the habit of always using my smallest side or smallest angle. So I know that sine of b, that's opposite my smaller side, over 7 is equal to sine of 108 over 13.89. Go ahead, whip out your magic calcs. We're going to do 7 times sine 108 divided by 13.89. That, of course, is going to equal sine of b. So we get 7 times sine 108, close that parenthesis, divided by 13.89. I get the sine of sine of b is equal to 0.47993. We're going to throw that into our calculator using the inverse sign. And I get that that angle B is 28.64. Now we're going to subtract from 180 once again to find A. So I'm going to do 180 minus 108 minus 28.64. My third angle is 43.36. So we've now solved this triangle, finding our 2 missing angles and our missing side. Okay, now we're going to talk about a third way to find the area of a triangle. Again, you know from your basic geometry that area is equal to 1/2 base times height. You also know from our last section in 6-1 that area is equal to 1/2 B C sine A, or any other combination of sides and angles. And now we're going to use, and we use this one when we have an SAS situation. Well, you should remember from geometry, at least remember the name, Heron. Heron's formula is used for when we have three sides of a triangle. So we're going to use this for SSS. So the formula for Heron's triangle is the area of a triangle is equal to the square root of S, and S is the semi-perimeter of the triangle. So 1/2 the sum of the three sides. So it's S times S minus A, the first side, times S minus B, the second side, times S minus C, the third side, the square root of that product. Let's do one example. This is fun. So I want to find the area of this triangle. It has a side of 7, it has a side of 14, and it has a side of 17. So using Heron's formula, which is right here, I know that my semi-perimeter is 7 plus 17 plus 14 divided by 2. 7 plus 17 plus 14 divided by 2 is equal to S. So therefore S is 24 plus 14 is 38, divided by 2 is 19. So S equals 19. So our area is equal to the square root of 19 times 19 minus 7, which is 12, times 19 minus 17, which is 2, times 19 minus 14, which is 5. So whip out your calculators. Let's find out what our area is. Our area is equal to, let's see, 19 times 12 times 2 times 5. Our area is equal to the square root of 2280. Whip that into your calc. So I got second radical, second answer. And my area should be, you should find that our area is, I'll do that in red so you can see it, 47.75. All right, folks, that's it for today. Wish we could do more, but that's all I got. If you want to do some more, give me a call. No, I'm just kidding. Okay, bye.